Hello friends, let's start with our next chapter, that is resolution. Today's topic is resolution and its types. So what do you mean by resolution? A resolution is the minimum distance between two objects that can be distinguished in an image. Resolution is mostly related to the image capturing. After capturing an particular image, how clear it can be seen, that is dependent on the resolution of that sensor or of that camera. The If it is looking blur or if it is looking clear, this all is dependent on the size of the pixel. So in remote sensing, resolution is used to represent the resolving power, which is the capability of identifying the two different objects. So if two different nearby objects or phenomena are clearly classified or clearly identified, then we have an perfect resolution of the sensor which we are using in a particular satellite. Talking about a digital image, it consists of pixels. So each pixel consists of an particular information of the objects, and this information represents the clarity of that object. See, for example, talking about the pixel size in resolution, here is an 3 meter by 3 meter resolution image where you can see that this is red color is the surrounding area and blue color is of house. So majorly you can see like this classification through pixel size. But when you are getting output of such type of pixel, you can see only a blue color over here. In the next image, when you are increasing the decreasing the resolution, decreasing the height of that sensor, then you get an image of 5 meter by 5 meter pixel size, that is here is 5 meter and here it is 5 meter. Accordingly, 30 by 30 meter means this is this side and this side, the square sides are 30 meter. Here the pixel is of 5 meter by 5 meter. So same area, but you get very detailed study where you can see that the surrounding area of the house is classified by different pixels, and each pixel have a certain information about that area. So this each and every pixel have different information. Likewise, this blue color also have different various pixels over here. Some of the pixels here can classify that in this one pixel you can see that there is red color and blue color. So this red color is the surrounding area, and simultaneously you can classify the blue color, you can classify the boundaries of the house and the nearby ground. So likewise, 5 meter by 5 meter image gives perfect classification and the output is like this. But here you can see that the area or one pixel which have major or large area covered by which phenomenon, that whole pixel in the output shows the same phenomenon. Like in this pixel, more area is covered by house, that is blue color. So similarly our output shows completely blue color. Here when you are studying, you cannot classify, so we need more precise image of 1 meter by 1 meter resolution, that is 1 meter by 1 meter pixel size, and here you can classify the perfect boundary of the house and of the nearby ground, and the output which we require is the perfect image through which we can classify the boundaries, classify the objects or phenomenon which are present on our remotely sensed area. So accordingly, resolutions have four different types. That is spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. Each resolution have its own different characteristic. So talking about first resolution, that is spatial resolution, it is the measure of area or size of the smallest dimension on the earth surface over which an independent measurement can be made by the sensor. So talking about the spatial resolution, it can be used to measure the area or size of the smallest dimension, means smallest objects can be measured by spatial resolution with different pixel sizes, and it can be remotely sensed perfectly. This spatial resolution is expressed only by the size of the pixel. Like in earlier image which we have seen, the perfect example is of spatial resolution, because it is completely depend on the size of the pixel, which is measured with comparison of the area on the ground, that is in meter, that is 30 meter by 30 meter, 5 meter by 5 meter, or 1 meter by 1 meter. The spatial resolution specifies the pixel size of satellite image covering the Earth surface. So accordingly, if we have an image of high spatial resolution, then the pixel size varies from 0.41 to 4 meter. And if we are talking about the low spatial resolution, so at that time we have the image with pixel size 30 meter up to 1000 meter or more than that. So these are the classification of spatial resolution, that is high and low. So high spatial resolution have more clarity, which shows more precise and clear image of smallest dimension. And if we have to only classify the land use or land cover, so we can use low spatial resolution sensors which have 30 to 1000 meter resolution. So here in this image we can see that if we have an image of 10 meter resolution, so here we can classify it very clearly, that where are the residential area, where is the water body, where are the roads. So 10 meter resolution area shows clarity. As if we take same image in 30 meter resolution, so we can see that there is a specific blur. And again, if we take an 80 meter resolution area at same height, so we can't classify any object or any phenomenon, that is point, line and polygon cannot be classified in this data. So these are the examples of spatial resolution. So as we take an high resolution image, we can easily classify the objects and boundaries. Talking about next resolution, that is spectral resolution, which is comparatively studied with the spectral reflectance, or spectral, that is visible rays are involved in this resolution. Depending on the color bands, we can classify the objects or image. These all things are dependent in the spectral resolution. So spectral emissivity curve is made to characterize the reflectance or emittance of the features or targets over a variety of wavelengths. So at a different wavelength in the visible radiations or in the IR radiations, we can classify the images. So different classes of features and details in an image can be distinguished by comparing these responses over distinct wavelength ranges. Broad classes such as water and vegetation can be classified by broad wavelength, that may be visible or NIR. And if we have to differentiate specific classes, that may be types of rocks or types of vegetation in a forest, so we need very specific and very fine wavelength ranges to separate these all uh, objects or phenomenons on the earth. So as we have seen in spatial resolution, we have high spatial resolution and low spatial resolution classification. Similarly, dependent on the bands of the color, we have three type of spectral resolution, that is high spectral resolution, medium spectral resolution and low spectral resolution. Talking about high spectral resolution, near about 220 color bands are used to classify any objects. So we can classify very fine objects in these ranges. When we have medium spectral resolution, at that time we can use 3 to 15 color bands or wavelength. So we have medium separation or medium differentiation in classes or features on the earth. And at low spectral resolution, we can use only 3 bands. Mostly it is used visible bands, that is green, blue and red, and blue, green and red. And so we get very less or very broad wavelength ranges, and only broad classes can be only classified by low spectral resolution. So mostly to have differentiation within very specific classes or very minute classes, we have to use high spectral resolution, which have 220 bands. So here we can see that if we are making spectral reflectance curve of a vegetation depending on the spectral resolution, so we get 0.4, that is blue color over here, then slowly 0.5, 0.6, and again in the 0.7. These all are here, these all are absorbed, and only the green color is reflected, and so we can see the spectra of vegetation is of green color. Okay, so this is the spectral reflectance curve of vegetation. Here you can see different satellites which have captured the image of an particular area with number of spectral bands. So as there are more number of bands, here same image shows different classification, and precisely we can identify or we can classify the broad classes of a particular image. Now, third one is radiometric resolution. This is a measure of sensors to differentiate the smallest change in the spectral reflectance or emittance between various targets. Actually, as spatial resolution is dependent on the pixels, or spectral reflectance, spectral resolution is dependent on the spectra or number of bands. Accordingly, radiometric resolution is dependent on a digital number, that is from 0, which have a power of 2. As it gets increased, the darkness or the brightness of the image is also defined. The radiometric resolution is mostly for the images of panchromatic sensors which have black and white color. The imagery data are represented by positive digital numbers which vary from 0 to a selected power of 2. Each bit records an exponent of power 2. So if we have 1 raised to 2, then we have a digital number of 2, and the maximum number of brightness level is available dependent on the number of bits. So if the sensor have 8 bits to record, then we'll get 2 raised to 8, that is 256 as a digital value. So accordingly, varying from 0 to 255, if we have 0 as a digital number, then we can get the image is completely white, and if we have a digital number of 255, that means there is very dark tone representing the image or representing the object. So if talking about with the example of an image, here we can see that here is the 2 levels, that is 2 raised to 2, that is 4 as a digital number. Here you can see only black, completely black or completely white. But if we have more proper image of 4 levels, that is 2 raised to 4, then here we can see that we have here it is 1 raised to 2, sorry, 1 raised to 2, that is only 2 levels. So here we get a very proper this type of image. When we have an image of 2 raised to 2 power, that is 4 level or 4 bit, at that time here you can see that slightly we can classify some or the few objects. But here when we have the 2 raised to 3 power, that is 8 level, then we can see that more, here we can identify these are the roads. Here you can see some bright ranges, that is there is maybe some buildings. Again here are few residential areas. Here it is the dark tone, that means here maybe the water. Like this we can classify. And when we go to 2 raised to 4 power, that is 16 level or 16 bit, then again we can properly classify. So like this we can, in this image we have shown that when there is purely white color, so it have a 0 bit value, and when there is very darkest tone of black color, so we have 255 as a value. So this is the example of radiometric resolution, which is dependent on the digital numbers given in a black and white image, which ranges from 0 to 202 255, and it is completely dependent on the exponent power of 2, that is 1 raised to 2, 2 raised to 2, 3 raised to 2 similarly. Next, or you can say last resolution, that is temporal resolution. Temporal, that means the images which are obtained after a particular time span. So we can use the spatial or spectral image after certain time intervals, and thus we can compare it as a temporal resolution. So temporal resolution is also called as repeativity of a satellite. That is, it is the capability of a satellite to image the exact same area at the same viewing angle at different period of time. That means we have a same area, we have a same angle of capturing, and the image is captured after a certain period of time, so it is called as temporal resolution. The temporal resolution is mostly used after any floods or after any earthquakes, any accidents like nuclear disasters or atomic burstings. Like this, temporal resolutions are helpful for such incidents. Mostly there are four major incident or four major situations when temporal resolutions can be. Persistent cloud offers limited clear views of the earth surface. If there is a cloud, so you can't take the image, so you have to take a image after a period of time. Short-lived phenomena need to be imaged. So when floods, oil slicks can be seen, earthquakes, volcanoes, so at that time, after a period of small time, we can take the images. Multi-temporal comparison are required. So when in agricultural, you can take multi-temporal comparisons like in Kharif, Rabi and summer season. If we have three seasons in agriculture, so you can take time the images, like in Kharif you have a different crop, in Rabi you have a different crop, and also in summer similarly. So you can help temporal resolution is very useful at such time. The changing appearance of a feature over time can be used to distinguish it from near similar features like wheat and maize, or you can say any flowering crop or any orchards. If it is a growing season, if it is sowing season, then you have a different image. When you have a flowering season, you have a different image. When there is a fruiting season of a crop, then you have a different image. So you can in a particular season also you can take the images of different span, and you can use this temporal resolution for your study. So similarly, as we have seen in spectral and spatial resolution, the temporal resolution is also classified as high temporal resolution, medium temporal resolution and low temporal resolution. In high, you can take the image within less than 24 hours to up to 3 days. In medium temporal resolution, you can take the image from 4 to 16 days. And in low temporal resolution, you can take the time span between two images which can be more than 16 days. So these are the classification of temporal resolution. Here is an example of Trinket Island, which is situated in Andaman and Nicobar. When tsunami was occur, so before arriving of tsunami on 21st December 2004, you can see the shape of the island was like this. Then soon after the tsunami occurred, that is on 26 December 2004, the satellite captured the image of tsunami island like this. You can see most of the area was covered by water. Here you can see, here in this image you can see a land, but here whole area was covered by water. Similarly, in this area particularly, you can see a major change here. This you can't see any type of land over here. Whole area was covered by water, And then much after the tsunami, that is in 4th January 2005, which you can say that after 8 to 10 days, when the water or the whole waves were stagnant, at that time the final shape of Trinket Island was completely changed. You can see how before the tsunami the island was like this, and after tsunami the shape of island was completely changed. The major effect, you can see that this area was completely changed only into such type of road only can be, or line can be remained after the tsunami. So likewise, temporal resolution helps to see the changes after different incidents or accidents on the earth. Here also in 15th November 2009 there was an atomic here like this there were four reactors, reactor 1, 2, 3, 4 of the company, but after the explosion on 14th March 2011, you can see in reactor 3 how the smoke came out and how the reactor got burst, and this area was completely affected by the blast. So likewise you can see the changes by temporal resolution. So here we have studied the spatial, spectral, radiometric and temporal resolution of any sensor. Thank you.